Good morning.
Morning.
Good. Okay. I just given persons maybe another 5 or so minutes to join, and then we could begin. Okay, I think we should begin at this time. Let's see, 4 persons, but can't wait much longer. Good morning, and trust everyone is fine. Are you all back with me? Mr. Butler, you there?
Good morning.
Good morning. Okay. Miss Bain?
Good morning.
Good morning. And Miss Roll? Miss Daniel Roll? Good morning. Okay. All right. And I guess I heard from Miss Field. Okay. All right. Today we are continuing with our schedule as outlined in the course outline that I would have given to you earlier. So we want to begin by looking at the homework. Last class we were focusing on percentages. I'm not sure if you had any issues with any of the questions. If you have any issue with any of the questions, the answers were provided to you. The answers are on the screen. So if you have any question in particular that you'd like me to look at, you could let me know now before we move on to the next chapter. Anybody have any questions with any of the homework? No?
My only thing is, do you send back like a grade for them, or these just like practice?
For the homework? Okay, now at the end of today's class, I will be sharing with you your what I call that now, like a grades record or a grade sheet, a progress report, and it's going to be a live report that I will share in with Google Drive using a Google Sheet. So each time you do a piece of work, I will just add your grade, your score to it. Now with the homework, once I see that you did the homework, you get 100% for the homework. I don't mark the homework. I give you the answers, and you will work towards. If you can't get the answer, you'll work towards it. But if you, for whatever reason, still not able to figure out how the answer was derived at, then this is the time for you to ask your question, and we could go through it. All right. So once you email the work to me, I'll record that you have done it. The homework does contribute a portion of your overall grade. Even though it's a small amount, sometimes it can be significant. So it is suggested that you do the homework, because the homework would also help you as far as when you have to do your tests, your midterms, and your final exam. We need the practice. What I do in class is not sufficient. You have to practice. So today you should have completed the percentage homework. If you did it, you can just email me a copy. Once I see that, I'll record that you did it. If I don't see a copy, then I'll just record that it was not submitted. Okay, so now the test that you did on Saturday past, towards the end of the lesson, we'll look at that also, and we'll have some discussion on that at the end. Okay. So I take it we got all of these questions right, or either that or we didn't do it. Or I need to call each person individually. Mr. Butler, any queries with any of those questions for homework?
Not as yet. I saw doing it in progress, but I'll get that to you by end of day.
Okay. What about Miss Heald?
I don't have any questions. I'll email you a copy before the class is over.
Okay. Miss Roll? Miss
No, Miss
Roll?
Allen, no, I don't have any questions.
Okay. Miss Bain? Thought I saw Miss Bain. Atia Knowles. So, oh, sorry, Branique Bain. Branique Bain.
Yeah.
Hello, Miss Bain?
I dropped off for a second. What was the question?
Yeah, I was asking regarding the homework, if you had anything that you needed us to look at, or you were straight with all the questions.
I'm fine with the questions.
Okay, all right. So that was Miss Bain. I think I see Mr. Messidor somewhere. Is he there? No. No, I don't see him anymore. Okay. Atia Knowles, are you there?
I'm good. Yes.
Okay. All right then. All right. Well, in that case, then I guess we can move on. So today, then we are moving on to look. Hold on. Am I at the right thing? Sorry, I think I didn't open the right thing. Let me double check here. Open with PowerPoint. Okay. So I need slideshow. Okay. All right. So today we're moving on to chapter 5, which is covers some basic algebra. The focus is on solving equations. And we're going to begin by looking at some basic terminology. I think most of this should be a review for you. So I'm going to play a short video, and I want you to listen out for some of those key terms that we should be familiar with in algebra. I'm going to play it and stop because last time I played, I think there was a problem with the audio. So let me try playing it and see if you're able to hear. Oh, okay.
In this video, we're going to look at some basic algebraic.
Did you hear the sound just now?
Yes.
Yes. Okay. So it's a few minutes, so about 4 minutes.
Vocabulary and the difference between an expression and an equation. So what is algebra anyway? Well, you've been doing algebra since the first grade. When your teacher put box plus 6 equals 10, you were actually doing algebra. Instead of using a box in the older grades, we'll use a variable, usually a letter, could be B plus 6, C plus 6, to represent a number. Well, what is a variable? Well, a variable is a letter that represents a number. In this first example, we have, this would be our variable y, and it represents some number. In this example, the variable would be m, and m represents some number. The variable here would be t, the variable would be x. This one has two variables. And this last example actually has 3 different variables. Each one of those would represent a different number. Well, what's an expression? The difference between an expression and an equation has equal sign, and that's where it gets its name. So an equation has an equal sign in it. An expression does not have an equal sign. So these are all examples of expressions, and algebraic expressions are a combination of variables and numbers. So here we have a number and a variable, and a number and a variable. It's a combination of numbers and variables. Well, what's a coefficient? A coefficient is the number that you will find in front of the variable. So for example, in this example, we have 2y. 2 is your coefficient, I mean 2 times y. 3 would be your coefficient here, that's 3 times x. 4 would be your coefficient here, And in this last example, it looks like there isn't a coefficient, but there's just one x there. So the coefficient is 1. You don't need to write the 1 there. 1x is exactly the same as just x. So what is a constant? Well, a constant in an algebraic expression, it's a number that stands alone and its value doesn't change. For example, I'm going to do this one first over here. Here is your constant. The number 2 is not going to change. It's always going to be positive 2. Down here, the constant is 5. It's always going to be positive 5. The constant here this is actually negative 8, and its value is not going to change. And this is actually negative 5. The constant here would be negative 5, and its value does not change. So let's write a few expressions. Let's practice using some of the terminology that we just learned. The variable is m. Okay, there's our variable m. The coefficient is 6. The 6 goes right in front of the variable. Write the expression. Well, there you go. 6m would be your expression for that first example. Let's look at the next one. The variable is h. The coefficient is 5. The constant is 5. Write the expression. So that would be 5h plus 5. The variable is t. The coefficient is 1. Now you can put a 1 there if you want. You don't have to. The constant is 4. So the expression for that example would be 1t plus 4, or just t plus 4. Either one of those is fine. So that's just a little vocabulary that we'll be using in algebra this year.
Okay, so just a bit of review of some terms as I'm sure all of you would have heard before. Is there any term there that's new to any of you never heard before? Anybody? Ms. Heald? We call on you.
No, sir.
Oh, nothing new. Okay. So
No.
based on what we just heard, I have a few definitions here, and I have the possible answers at the bottom. So let's look at the first one. I'm going to call on persons. The first person I'm going to call on is Mr. Butler to tell me, for the first one, it says a meaningful combination of numbers and letters called terms. What is the meaningful combination of numbers and letters? Look at the one, we have 6. 1, 2, 3, 4, 5, 6. Which of those you think best describes number 1, Mr. Butler?
You're trying to see, but like the bar to the bottom over it. So bear with me. Is it equation?
No, equation wouldn't be it. No.
All right. Yeah. I'm trying to glimpse it, but the only one I can think of next is, okay, you see it now. Expression.
Expression. Okay. So that would be your expression. Okay. Ms. Heald, the next one says a mathematical statement with an equal sign showing that a mathematical expression on the left equals to the expression on the right. Ms. Heald?
Hi.
Yes. What's the answer for the second one?
Equation.
Okay. That's an easy one, the equal sign. Okay. Okay, it's telling that one side of an expression is equal to the other. Okay, separated by equal sign. That's your equation. All right, now this one, number 3, it wasn't mentioned in the video, but you should be able, through the process of elimination, figure out which one that is. Ms. Roll, can you figure out which of those terms would match an equation that expresses in symbols a general rule, fact, or principle. It wasn't mentioned in the video, but
Formula?
formula, yes. Okay. So a formula is a type of expression, a type of equation. It's a type of equation. It is an equation, but it's one that gives you a general fact, rule, or principle. And many of you should remember some of the formulas that we use in school, like the formula to find the area of a rectangle, find the area of a circle, find the perimeter of a rectangle, and so on. All of those are formulas. Those formulas are equations, but those equations help us to apply a principle. When we use a simple interest formula, when we use the formula we used last week for portion, those are formulas which are also equations. All right, Ms. Bain. Number 4 says symbols, usually letters, used to represent unknown values.
Variables.
Variables, right, okay, so variable. Okay, Mr. Messidor. The next one says known values represented by numbers.
Constant.
Constant, yes, sir, constant. And then the last one, I guess we should be able to figure that out based on what have been used. I think I see Ms. Thompson there. Can you answer that last one? Ms. Thompson, are you with us?
Morning. Yes,
Good
sir.
morning. Yes, the number 6.
A number placed before and multiplying the variable in it. Is that no coefficient?
Coefficient. You had missed the video. Eh?
I did.
Okay, all right. Coefficient is correct by the process of elimination.
Yes.
One. Okay, so the coefficient, a number placed before and multiplying the variable in an algebraic expression is the coefficient. Okay, so those are some basic terms we'll be using in this chapter. And like I said, I think for most of you, you'd have heard them already, but I guess over the years, you might not have used them. But for this chapter, we'll be making use of some of these terminologies. Okay, so this is the answer. So when I send the PowerPoint to you, this would be there. Of course, this wouldn't be there because this is what I just wrote in. So this will be there. All right, so something that was mentioned in the video, this is on page 119 of your text. They make reference to variables and constants. So here we're looking at variable and constant rules. So the first rule says that if no number is in front of a letter, then essentially what they're saying is that the coefficient is 1. Okay, so that was mentioned in the video. So in the example that they have here, B is the same as 1B, C is the same as 1C, but we don't necessarily need to write the 1 in front of the letter if the coefficient is 1. I don't think this was mentioned in the video. I'm not sure if it does, but it says if no sign is in front of a number or letter, then it is considered to be positive. So C is the same as positive C, 4 is the same as positive 4. So if you don't see a symbol in front, then you take it to be positive. All right. And so one of the things we should be able to do with algebra, the purpose, as was mentioned in the video, is that, you know, in the early school, primary school, we used to use a box to represent the unknown. So for the first one where it says Dick's age 8 years ago, you would put a box -8, but algebraically, we use a letter to represent the unknown, which of course is your variable. In the second one, we would have box +8, trying to figure out what should go in the box. In this next one, we'd have 4 times a box. And then the next one, it would be the box over 5, okay? Representing your unknown. But algebraically, we use letters to represent those unknown quantities. So I want you to now look at these 6 statements we have here. We want to write them algebraically. And in this case, we're using Q as the variable. So the first one says 9 less than 1/2 a number is 14. So when we hear the word less, what operation comes to mind?
Subtract.
Subtract, okay? So we definitely know we have to subtract. We know that the result is equal to 14, okay? So it says 9 less than 1/2 a number. So what are we subtracting here?
Half Q minus 9.
Half Q minus 9 equals 14, okay? And another way we could write that is Q over 2 minus 9 equals 14. That's the same as dividing Q by 2, which is half of Q, okay? All right, the next one, it says 8 times the sum of a number and 31 is 50, sorry. 8 times the sum of a number and 31 is 50.
AQ.
8Q,
Plus 30.
plus, well, this is 31.
Oh, my bad. Plus 31 equals 50.
Okay. Now, there's a little trick to this one because it says, it doesn't say 8 times a number and 31 is 50. What we have here with this 8Q plus 31 equal 50, that is actually saying 8 times a number plus 31 is 50. But the question is saying 8 times the sum of a number and 31 is 50. So something is missing in that. What's missing?
The bracket.
Bracket.
Brackets, right. So we need to put the bracket around the Q and the 31 because it's the sum of those two that we are multiplying by 8 to get 50. Okay? So we have to look out for those type of questions that actually want you to do the sum rather than just one item. Okay, the next one, C says 10 decreased by twice a number is 2. 10 decreased by twice a number is 2. Anybody want to tackle that? Or I need to call someone?
Is it 10 subtracted by Q squared? 2?
2.
I
You said 10?
squared.
You said
Because it
squared?
says twice the number, yes.
Yeah, the number, what is the number? Remember, we're using Q to represent the number. We're using Q to represent the number. So it says 10 decreased by twice a number. We don't know what the number is, but twice the number would be what in algebra terms?
So 2Q. 2Q.
Right, right. And that's equal to?
2.
2. Okay. All right. So 10 minus twice a number is equal to 2. So that's how you'd represent that. Okay, in the next one, it says 8 times a number less 2 equals 21. 8 times a number less 2 equals 21. Mr. Messidor, I don't think I've heard from you. You want to tackle that one?
Oh boy. 8 times a number less 2 equals 21.
Mm-hmm.
So we would put the 8.
Mm-hmm. And remember, we're using Q to represent the number,
Right.
which we don't know.
Okay, I guess you could put it maybe in bracket Q squared.
Okay. Let's read what it says. It says 8 times a number less 2. What does less 2 mean?
Subtract.
Okay, so you're going to subtract what? You're going to subtract 2, and that's going to be equal to? What does the question says equal to?
21, bro.
21. But we still have something missing there. 8 times a number less 2 equals 21. What's missing in that?
The Q
Where are we going to put the Q?
after the 8.
Okay, so that's it. 8Q minus 2 equals 21. 8 times a number less 2 equals 21. Okay, thank you, sir. All right, the next one says the sum of 4 times a number and 2 is 15. The sum of 4 times a number and 2 is 15.
Would it be open bracket 4Q plus 2 equals 15? I mean, plus 2, close the bracket, equals 15?
Okay, so the sum of 4 times a number and 2 is equal to 15. Okay. The last one, if twice a number is decreased by 8, the difference is 4.
Would it be 2Q minus 8 equals 4?
Equals 4. Okay, if twice a number is decreased by 8, the difference is 4. Very good. All right, so that was a little exercise in writing statements, worded statements in algebraic form. And once we have it written in algebraic form, in each case there we have an equation, then we could go ahead and solve those equations to find what the missing number is. So we're going to move on then to actually review the process of solving equations. Okay. And so, let me see now. Oh, this thing didn't show. Okay. All right. So if you look on page, those who have the book, page 119 of your textbook, the rule they have there for solving for the unknown, it says whatever you do to one side of an equation, you must do to the other side. Now, I have a scale here, but for some reason the scale is not showing on this. So basically what the scale look like in your book, you'll see it. And it is showing that if you have that the scale should be in balance. So whatever you do to one side, you have to do to the other side to keep the scale balanced. So if you have on the left-hand side, a plus 8 is equal to 58, you want to find what a is. That means you're going to have to remove this 8. So if you remove 8 from this side, then you have to do the same thing on the other side, and that will keep the equation in balance. So that's one of the concepts we use for solving equation. Whatever you do to one side, you have to do the same to the other side to keep the equation in balance. All right, so if you have to add to one side, you do the same to the other side. If you have to subtract from one side, you do the same to the other side. If you have to divide one side, you divide the other side. And if you have to multiply on one, you do the same to keep it balanced. Now in your book also, they make mention of what they call opposite process rule. It says in an equation, if an equation indicates a process such as addition, subtraction, multiplication, or division, solve for the unknown or variable by using the opposite process. So each operation has its opposite. So the opposite of addition would be subtraction. Of course, the opposite of subtraction is addition. And then multiplication and division, they are opposites. So to multiply, if you have an equation with a multiplication, to solve it, you can do the opposite, which is divide, and vice versa. If it was division, to solve it, you would multiply. All right. This next one, the equation equality rule, which is also on page 119, 120 of your text. Basically, it's saying the same thing we mentioned with the scale. You can add the same quantity or number to both sides of an equation. You can subtract the same quantity, okay, without affecting the equality of the equation. You could also divide or multiply both sides of the equation by the same quantity, except 0, without affecting the equality of the equation, all right? And so those are some concepts we use when solving equations. So we're going to look at some examples now. So in this first example, this would be similar to what we're looking at with the scale. A plus 8 is equal to 58. A very simple example. It's just one operation. So what they did here, they use the opposite rule. So since you're adding 8, to get rid of that 8, you have to do the opposite, which is to subtract. So since you subtract 8 here, you have to do the same thing here. All right. So you're doing the opposite, but because you want to keep it balanced, because you're subtracting 8 from the left, you have to do the same thing on the right. So you use the opposite operation to help you to solve it, but whatever you do on the one side, you have to do the same on the other side. So end up that 8 is equal to 50. In the second one, b minus 50 is equal to 80. In order for you to solve, you do the opposite operation. In this case, it was a subtraction, so you're going to add 50. When you add 50 plus negative 50, you get 0. So b will be on the left-hand side by itself. But since you're adding 50 here, you have to do the same thing on the right-hand side. So b equals 130 when you do your addition. So those are simple one operation equations. And we move on to look at multiplication and division. Same process. So this one says 7g is equal to 35. Only one operation we're looking at. So if you want to eliminate the 7, you have to divide by 7. The opposite of multiplication is to divide. Remember now, 7g is the same as 7 times g. So the opposite of that would be to divide. So we divide by 7 to get rid of the 7. So we're left with g on the left-hand side, but we have to do the same thing on the right. So when we divide the 35 by 7, we get g equals 5. And you'll see now for this last one, v over 5 means v divided by 5. So the opposite of divide is to multiply. So you'll see where they multiply by 5, 5 times v over 5. So it cancels out the 5, so you're left with v only. But since you multiplied the left by 5, you have to do the same thing on the right. So you multiply the 70 by 5 to get 350. And you'll notice in your book, for each of these, there's a check. So right here is your check. Check to see if your answer is correct. The answer you got was 50. When you add the 50 to the 8, that was A plus 8 is 50. 50 plus 8 gives you 58. So you get back that 58 that you started with. In this second one, to check your answer was 130. 130 is what represents B. Subtract 50 from 130, you get 80, which is what the question had. Same thing for the next two. You got G is equal to 5. 5 is the answer. So if you put the 5 in place of G, 7 times 5 is 35. So you get the 35, which is what was up here. And the same thing with this last one. Your answer is equal to 350. So if you put the 350 in place of V up here, 350 divided by 5, this is what they have right here. 350 divided by 5 gives you 70, and the 70 is what was in the equation originally. All right, so you could always, with equations, one of the good things with equations, you can always check your answer by substituting the answer into the variable and working out the question to see if it works out according to what the equation stated. So those are some very simple equations with just a single operation. Of course, equations don't always come like that. We have equations with multiple processes. And so we're going to look at an example here where it says, so on your book on page 121, they talk about the multiple processes rule. Now, most of you probably will remember the steps for something like this, but in your book, they give us a process rule, which says that when solving for an unknown that involves more than one process, do the addition and subtraction before multiplication and division. So in this equation here, you have two operations. The first is a division right here. You're going to say h divided by 4 plus 2 is equal to 5. So what they're saying to you is the first thing you must do is your addition and subtraction, and then you deal with the multiplication and division afterwards. So you have an addition here. So you're going to deal with that first by doing the opposite. The opposite of add is to subtract. So that's why they end up subtracting 2. Subtract 2. So when you subtract 2, you're going to end up with just 8/4. And subtract 2 from 5, you get 3. Then after you do the subtraction, then you deal with the multiplication and division. So this was a division, h/4 equals 3. So the opposite would be to multiply by 4. So you multiply by 4, it ends up canceling out the 4 that was on your denominator. So you end up with h equals to 4 times 3. You multiply this side by 4 as well, 4 times 3. So h is equal to 12. And you could check your answer by putting the 12 in place of h. So if you put 12 in place of h, it's going to be 12 divided by 4 plus 2 equal 5. You check. 12 divided by 4 is 3. 3 plus 2 equals 5, which is what we had up here. So that's how you check your answer for the multiple process. Let's look at another one. Now in this one, we have parentheses, another name for brackets. And so the important thing to remember here is that you have to treat everything in the brackets as 1. So whatever you do to one, you have to do to the other. So in this first one here, it says 5, open brackets, p minus 4, close brackets equal to 20. So if you want to remove the bracket, it means then this 5 has to be applied to both the p and the 4. So that's why the 5p is equal to 5 times p is 5p, 5 times 4 is 20. So 5p minus 20 equals 20. And once you do that portion, then you just continue solving as regular. The opposite of subtract would be to add. So you add negative 20 plus 20, it's going to eliminate the 20. So you're going to end up with 5p equals 20 plus 20 equals 40. Okay. And so p then would be equal to 40 divided by 5, which is equal to 8. And you could always check your answers you see here by putting the 8 in place of P. So that's the 8 is taking the place of P. 8 minus 4 is 20. 5 times 4 equals 20. And that's your result of the check. Okay, so let's look at this next one. Here, we have an equation where you have two sets of like variables. So this is 4a plus a equals 20. Okay, once the variables are alike, we can combine them by adding them or subtracting them. 4a plus a gives you 5a. Once you get that, you follow the process that we used before. Since this is only one operation, it's 5 times a, you're going to divide. So you divide by 5, and you get a equals 4. And you could always check your answer by substituting the 4 into the equation. So 4 4s 16 plus 4 equals 20. All right, so based on what we just looked at, I have 6 questions here. I want you to attempt them. I'll give you a couple minutes to work on these 6 questions, and I'm going to call on persons to just explain what they did. Now, of course, you don't have to necessarily set it up the way the book have it, because there are some shortcuts we could use, but just explain what you did once I call on you. Okay, so I'll give you a few minutes to do that. Okay, so let's begin with
Oh, gee, going for this.
yeah, you could continue. I just want to begin with someone. Let me see. Miss Thompson, you could do number 1 for us, please. Tell me what you did.
Ah, not really.
Number 1, the first one, A. That's all you're doing. Tell
I
me what
know.
you did. Okay, well, you could do it together now.
That's more like it.
Mhm.
Okay, so B plus 14 equals to 17. What we did was B minus 14 equals 7. I'm Mr. Allen, I'm not sure how to do this. I just learning this. I don't know. I have to go, but I'm not the kind of learn. I have to go back and practice it before, because you're moving so fast.
Okay, Miss Thompson.
Yes, sir.
It says B plus 14 equals 70. So what that is saying to you, a number plus 14 is equal to 70. We're trying to find what the number is. So what is the opposite of addition of 14?
Subtract.
Okay, so if you want to do it like that, you could say B plus 14 minus 14 equal to 70 minus 14. All right, because you want to do the same thing to the two. So if you have to subtract the 14 on the left-hand side, you have to do the same thing on the right-hand side. Okay?
Okay.
So to keep the balance. So if you have B plus 14 minus 14, what's going to happen with those two numbers? What's going to be the result?
Cancel out.
Okay,
They cancel out.
so you're going to have B then is equal to 70 minus 14 gives you what?
56.
Okay, that's it, 56. All right, so that was a single operation that we're looking at. And so all we do is look for the opposite operation and do that to both sides. Okay, so since it was an addition, we're going to subtract the number on the two sides. All right, thank you. All right, Miss Roll, Daniel Roll. Let's look at number 2.
Okay, I did A well, but I was confused with B.
Okay, now it says D plus 4D is equal to 250. Now, if you add D plus 4D, what you going to get?
If I add D plus 4D?
Yes, ma'am. How many D's will you have?
2. So
no. If you have 4 D's and then you have another D, how many D's
5D.
do you have? Okay. So you combine the like terms. So I'm going to put a line here to separate. So that's going to be 5D is equal to 250.
Oh, okay.
So now
we divide. Okay. I was confused with the first piece. So we divide the 250 by 5.
Okay, so you divide by 5. So this is going to cancel it out. Right, so D is equal to 50. Okay. All right.
Okay.
Good. Okay. Miss Bain. Miss Bain, tell me what you did for C, or let's do it together.
Okay, for C, I did, it's 11B equals 121. So that's technically 11 times B. So I did the opposite. I did 121 divided by 11, which gave me 11. So B equals 11.
All right, so 11B divided by 11 equals to 121 divided by 11. So you cancel out the 11 there. So you're going to end up with B equals, you said 11? 11 into 121 is 11. Okay. All right. Mr. Messador. Let's look at D.
Okay, D, where's the B?
B
Right,
over
so,
8
yeah.
equals 90.
Okay, so we would obviously do the opposite of B divided by 8, right?
Yeah. What's the opposite of that?
B over B. over 8 times 8.
Okay. So B, let me put a line here. B over 8 times 8 over 1 equals 90 times 8. Okay. So you're going to cancel out that.
8.
So you're going to get
B
B equals
720.
720. Okay. Thank you. All right. Miss Hield. The question E. Miss Hield? Is she there? Let's see.
Hi, I'm here. Sorry, my phone locked. I had to unlock it.
Okay.
Okay, so we on E?
Yes.
Okay, so I did 250. I carried the 2 over, so I did 250 take away 2 equals 248. And
Okay,
then
so
I
B over 2 plus 2
2.
minus 2 equals 250 minus 2. All right. So that's going to eliminate it's going to eliminate that. So you're going to end up with B over 2 equals 250 minus 2 gives you
248.
248. All right. So the next line then you will have, what did you do next?
Multiply the 248 by 2, and it gave me
Okay.
496.
All right. So B over 2 times 2 equals 248 times 2. So this 2 going to cancel that, and that's going to give you B equals, you said 496? 496.
96.
Okay.
Yes.
All right. Okay. Thank you, Ms. Hill. Mr. Butler? Question F.
All right. Give me a minute. 3b minus 6 equals 18. Therefore, we're going to work the left side. So we're going to multiply everything.
Okay.
So it's going to be 3b minus 18 equals 18.
Okay. All right.
Then we're going to work the right side. And so the line is going to be, which cancels out the 18. So on the left.
How are you going to cancel out the 18?
We're gonna add it. We're gonna add on the left. So it'll be 3b equals 18 plus 18.
Okay. So this cancels out. So
yeah.
3b equals 36. Okay.
Now we have to cancel the 3. So we have
Okay.
to divide each side.
3b over 3 equals 36 over 3. So that cancels out that. So b would be equal to
12 for final result.
12. Okay. Thank you. Okay, so now those persons who I think 1 or 2 persons did express that, you know, we were moving a little fast. I hope you're taking notes of all the questions we did, writing down, so you have examples to look at. And of course, in your book, if you have the textbook, all of these questions, they have worked examples that you can also use to guide you. But please copy as we make these notes on the screen. Please copy them off in your notebook, so that you have something to follow when it's time for you to do your practice for homework. And that's why I give the homework for the extra practice. I give the homework, I give you the answers. You could check, make sure you work out how to arrive at the answers given. If you have a problem, Next class, you can let us know and we could discuss it and show you the steps or review the steps. Okay, so a lot of this, especially because we're doing this virtually, you have to do some amount of practice on your own. And like I said, once you are unable to figure out how an answer was arrived at, then you could always let us know in the class and we could discuss it. All right, so those are some examples of equations. You'll get a few to practice for homework. Okay, so I guess by now all of you should have copied off or made the corrections necessary if you had any issues with any of these. But the questions we looked at here are basically going to be the format for the questions in your homework. You're going to either have a single operation like question A, D, single operation, C, single operation, or you're going to have multiple operation like E. F is also a multiple operation, but it's including brackets. And then B is where you have to combine like terms. Okay, so we have a number of different scenarios here. Single operation, multiple operation with brackets. Okay, so those are the general formats that the equations will follow.
Excuse me, Mr. Allen.
Yes, ma'am.
Is there another way that F can be done?
Let me hear what are you suggesting?
I know, that's why I'm asking you. 3B, does that minus sign change or say I want
3 times B would be 3B minus 6. 3 times minus 6 is minus 18 equals 18. That's the second step. Now, some people they will do a shorter method than what we did. Instead of going through all the addition and subtract opposite operation, they'll just go next step would be 3B equals 18 plus 18, which is equal to 36. And then they'll just go B equals 36 divided by 3 equals 12. So that's a shorter way to do it. But I don't know of any other way, either the long way, which we did, where we show all the opposite operations, or we could do the shorter method that I just explained. If you know of something else, you could let us know, and then we could look at it. Is there another approach you are thinking of?
No, that's fine.
Okay, all right. Okay, now the challenge often comes right here, where we have to solve equations, because we're going to have to read our questions carefully. We have to write the question into an equation, and then we're going to have to solve the equation and answer the question that was asked. So you will see on page 123 of your textbook, they give you some guidelines as to how you can go about solving equations, or solving problems using equations, I should say. Solving word problems. So the first thing they ask you to do is read the problem. Read it entirely, and sometimes you may have to read it a second time. Then ask, what is the problem looking for? Then you're going to choose a variable to represent the unknown quantity you're looking for. Then it says you must visualize the relationship between the unknowns and the variables, then use that to set up an equation to solve for the unknown. And then 5th to check your result. So in your book, you will see this little table here, which they refer to as the blueprint aid. So after you read, you're going to deal with the equation, choosing a variable. That's step number 3. Okay. And then you're going to, you're going to say what you're going to put this in word form. What are the unknowns? Then you're going to, step 3, which is actually choose a variable to represent. It doesn't have to be X, any letter. Then you're going to write your equation. And then you go ahead and do the solution. So let's look at an example. So this first example says today on sale at a local Stop and Shop supermarket, the price of a 1-pound can of chock full of nuts coffee is $9.99. This is a $2 savings. What was the original price of the can of coffee? Okay, so we start off a little simple and then we'll step it up, but to just so you get the concept. So they ask, what was the original price? So that's what you asked for. So that's the unknown is right here, original price. You don't know the original price, so you're going to use a variable to represent it. And in this case, they chose P. Okay, so P is representing the unknown, which is the price of the chock full of nuts, the original price. Then it says the price is that they gave you, that $9.99, is a $2 savings. That means that $2 were taken off the price. So whatever the price was before, whatever it was before, the original price minus 2 is going to give us this new price, which is $9.99. So if you want to find the original price, then we have to solve this equation. P minus 2 equals $9.99. So how will we solve that equation? P minus 2 equals 9.99. How are we going to solve that? What's the solution?
P equals
Carry the
999 plus 2.
Okay. Plus 2. So P equals 11.99. And you could always check your answer by saying, okay, this is a $2 savings. So if you have to save $2 off $11.99, that means you're going to subtract $2 from it. So $11.99 minus 2, this is your check to see if your answer is correct. It gives you $9.99. Okay, and that's what we had in the question up here. $9.99 was the price for the discounted coffee. Okay, so I want you to look at this question. Similar to this one. I'll give you a minute or two. Say what is the unknown. Choose a variable. Write relationship based on that. Give you a minute to do that. Okay, so let's start with Miss Atia Knowles. Could you read the question?
US Air reduced its airfare to California by $60. The sale price was $95. What was the original price?
Okay, so what was the unknown, Miss Knowles?
I know, I do it yet.
No, but you could look at it and tell me. I don't want you to give me the answer, you know. I want you to look at in this table here. What is it that you're looking for? What does the question ask you for?
Okay, the original price.
Okay, so original price. That's what we're looking for. All right. So give me a variable that you're going to use to find the original price. Just choose a letter.
A.
Okay, so we're going to use A. So now, based on what the question said, how could you write an equation to find the original price?
I don't know. What's that? Okay. 95 A. I don't know, minus 60.
Okay, so listen to what it says. It says it reduced its airfare by $60. So whatever the airfare was before, they reduced it by $60, and now the new sale price is $95. So we don't know what the original price is, but we reduce it by $60, and the sale price is $95. So when you hear reduce, what comes to mind? What operation?
Subtract.
Okay. So what you're going to subtract the 60 from?
The A, the variable.
The A. So A minus 60 equals
95.
95. Okay.
And A equals 95 plus 60.
So A equals?
155.
Okay, 155. So the original price was 155, and you could always check, say 155 minus 60. What does that give us?
95.
$95. All right, and that's what they said the sale price was. So this is just your check. All right, you don't have to do a check, but it's always useful to do a check to see if your answer is correct. All right, so we finished off by saying the original price was $95. Sorry, not 95, 155. Okay. Okay. So that's a fairly simple, just one operation we're looking at. You reduce the price to get something. So that means whatever it was, you subtracted from it to get this new sales price. So you write your equation to represent it, and then you solve. Okay, let's look at another form of word problem. Okay, so in this word problem, it says you're finding the whole when a part is known. So it says a local Burger King budgets 1/8 of its monthly profits on salaries. Salaries for the month were $12,000. What were Burger King's monthly profits? So you see here where it says the unknown we're looking for is monthly profits. We are going to use, in this case, they use P to represent the monthly profit. And they're writing now the relationship. It says a local Burger King budgets 1/8 of its monthly profits on salary. And salaries was 12,000. So that means 1/8 of the profit which would be 1/8p, is equal to 12,000. Okay, so 1/8p equals 12,000. Now, another way to write 1/8p is to simply just put p over 8 equals 12. So if you want to find p, what we're going to do? What's the opposite of divide by 8?
Multiply.
Okay, so that would be 12,000 times 8, which would be $96,000. And we could always check our answer by dividing that 96 by 8, and that should give you 12,000, which is what they said they use for salaries. All right, so that is finding the whole when a part is known. So let's look at this one here. Oh gosh, this one is so similar to that one. Okay. All right, but anyway, go through the steps for it, and then I'm going to call on someone to do that one.
Mr. Allen,
Yes, ma'am.
could you just go back to the last screen for 2 seconds for me?
Okay.
Thank you.
Okay. Okay, we're going to start with Ms. Bain.
Okay. We'll have to work it out because I wasn't finished.
Yeah, we could work it out together, no problem. So tell me, what is the unknown here?
The unknown is the budget.
Okay,
The total
so
budget.
we're looking for total budget. Okay. And so what variable you want to use?
We can use B.
B, okay. So based on what they told us, it says 1/8 of her budget for school. Kay McCartney spends 1/8 of her budget for school. What is the total budget if school costs 5,000? So how would you express that algebraically?
Okay, we can do 1/8 take away B, subtract B.
Why are you
No?
going to subtract? It says 1/8 of her budget for school. What
Okay,
is
1/8 B. Equals 5,000.
Okay, so 1/8 of the budget is used for school, so 1/8B, and since she used for school is 5,000, so 1/8 of that budget is 5,000. All right, now, like I said before, if you have 1/8, that could be written as, so 1/8B is the same as B over 8, so that's equal to 5,000. So if B over 8 is 5,000, how can we find B?
We're gonna multiply 5,000 by 8.
Okay, so B would be equal to 5,000. The opposite of divide would be to multiply. So B equals what? 5,000 times 8 gives you
40,000.
40,000. And if you want to check this answer, what you're going to do?
We're going to
You're going to put the 40,000 in place of the B. Okay, remember we say 1/8 of the budget is school. So you're going to find what is 1/8 of 40,000. So 40,000 times
Okay.
1/8. And that gives you what?
40,000 divided by 8 gives you 5,000.
Okay. So 1/8 then of 40,000 is 5,000, which is what the question said she spent for school. Okay. So that's why you would check that. Okay, so we have 6 different formats that your book have in terms of word problem setup. And so we are looking at number 2. So number 2 is finding the whole when a part is known. So we know that 1/8 is equal to 5,000. So in order to find the whole thing, we would set up an equation showing the fraction. And because this was a fraction where you have to divide by 8 to solve it, you would multiply by 8. Okay. And so we get, in this case, that the total budget was 40,000. Now, in the third scenario, which is found on page 125 of your book, they mention what they call difference problems. So in this case, a company sold 4 times as many computers. One company called ICM company sold 4 times as many computers as another company called Ring Company. The difference in their sales is 27. How many computers of each company were sold? So the unknown, according to this now, we don't know how many ICM sold, we don't know how many rings sold. So we end up with two different things that we want to find. They want to know how many computers of each company were sold. And there's 2 companies we have, ICM and Ring. So you will see at the bottom of the screen here, a note. If problem have 2 unknowns, assign the variable to a smaller item or one who sells less. Then assign the other unknown using the same variable, use the same letter. Okay? So if you look at the question, it says ICM company sold 4 times as many computers as Ring Company. So ICM sold more, Ring sold less. So therefore, you're going to use the variable to represent Ring. And so that's why we have a C here. And since it says that ICM sold 4 times as many, that means then ICM would be 4 times what Ring sold. So that's why we end up here with 4C for ICM and C for Ring. Company that sell the least amount, you give the variable to that, and then you express the other one in terms of that amount based on what the question says. And then it says the difference in their sales. Difference mean you're going to subtract. So 4C minus C is equal to 27. So that's how we will express that algebraically. And so once we solve that, we have 4C minus C would give us what?
3C?
3C equals 27. So therefore, C would be equal to 27 divided by 3, which is equal to 9. But that still doesn't help us to fully answer the question because they ask you how many computers of each company were sold. So what is that C representing? Which company is the 9 representing?
Representing Ring. We still need to find
ICM.
ICM.
Okay, so C is representing Ring Company. And so you have to find ICM now. You're going to have to say equals to 4 times 9, which is equal to 36. So ICM would be 36. And so to check your answer then, it's saying one company sells 4 times, the difference in their sales is 27. So if you take away 9 from 36, do you get 27? This is your check. 36
Yes.
minus 9 gives you, you said
20.
27? Okay.
Mm.
So so it does work out then that number works for what we are trying to find. So you'd finish off by saying ICM sold 36 and Ring sold 9. Okay? So this is an example of a question where you're looking for the difference. All right, so I'm gonna move then to look at one which I want you to do, so, sort of similar. So I'm going to ask Mr. Messidor. Mr. Messidor, you want to read that question?
Okay. John sold 8 times as many suitcases as Rick. Difference in their sales is 280 suitcases. How many suitcases did each sell?
Okay. So what are we looking for?
We are looking for how many suitcases did each of them sell?
Okay, so who are they?
I mean, Sean and Rick.
Okay, so we're looking for John's sales
and Rick sales.
And Rick's sales. Now, because we have 2 sets of things we're looking for, the suggestion is that you represent the smaller amount using the variable. So who sold the least amount?
Rick sold the least amount.
Okay, so give me a variable for Rick's amount.
Rick, I guess we could put S for suitcases.
Okay, all right. So if S is for Rick, how much would be for John?
8 times as many suitcases as Rick. So
okay, so
yeah, S equals.
No, I just want you to tell me 8 what? 8S.
8S, yes. 8 times.
Right. Okay. So because we know that Rick sold S amount and John sold 8 times as many, then his sales will be 8S. Now, in this section, now we're going to write the relationship or write the equation to represent what happened between them in terms of sales.
Okay. So
it says the difference in their sales is 280. What do you mean by difference?
That means we're subtracting the sales that Rick made from John's.
Right. Okay. What happened? Okay. So it's going to be then 8S minus S is equal to what?
280.
280. Right. Now, when you subtract 8S minus S, what do you get?
You have S equals 2.
No.
Yeah.
If you have 8S and you take away 1S, how many S's do you have left?
Oh, 7S. Sorry.
Okay. So 7S is equal to 280.
Right.
So S now, how are we going to find S if 7S is equal to 280?
Right. So 280 divided by 7 because we're going to do this.
All right. So that's equal to 280 divided by 7, which gives you
40.
40. So what does that 40 represent?
Difference in sales between Rick and John.
No, that 40 is telling you that the person who made S amount of sales, their sales is 40. So who is that?
That's S.
So who is S representing?
Rick. Sorry, Rick.
Rick. All right. So Rick sales
Equals 40.
equals 40. And so what would John sales equal?
40 times 8.
Okay. 40 times 8, which is equal to
20.
320. All right. Now, checking the answer. The difference in their sales is 280. How could we check that? What we're going to do to what numbers we're going to subtract to find if it gives you
320 minus 280.
No, not 80.
320 minus 40.
40. Okay,
Three
equal
times.
280. Okay, so that means that represents the solution to our question, because when you subtract 40 from 320, you get 280, and the question says the difference in their sales is 280. All right. Thank you, Mr. Messidor. All right, so that's scenario number 3. Any questions with that? Okay, we can move on then. All right, in scenario number 4, they call it calculating unit sales.
Sorry, excuse me, Mr. Allen, could you put it back to that slide for a second, please? Thanks. Thank you.
Okay. So in the scenario number 4, it says, together, Barry Sullivan and Mitch Ryan sold 300 homes for Regis Realty. Barry sold 9 times as many homes as Mitch. How many did each sell? That sounds very similar to what we just did, but what's the difference between those two? Anybody could tell me what's the difference between what we're doing now and what we just finished doing?
They want the total of both persons together, or they're saying the total of both persons together.
All right, very good. So in this case, they're telling us what the sum of the 2 persons sold, whereas with the other one, they're telling you the difference. Okay, so you end up subtracting in this scenario number 3, but in scenario number 4, they're giving you the sum of the sales for the 2 persons. So we're still trying to find 2 unknowns. We're trying to find how many Barry sold, how many Mitch sold. And again, they suggest right here, it says assign H to Ryan since he sold less. So whoever sold less, you use the variable to represent that person. So in this case, we put the H, since they're using H for the variable, and the other person sold 9 times as many. So his sales would be 9H. So altogether, they sold 300. So you'll have 9H plus H equals 300. So when you add 9H plus H, what did we get? What is 9H?
10H.
10H is equal to 300. So therefore, H would be equal to 300 divided by 10. H equals 30. So that 30 then would represent whose sales?
Mitch.
Mitch. Okay, so that would be Mitch's sales. And so if you want to find the other person's sales, then you would have to say, in this case, Barry, you would have to multiply that 30 by 9. So Barry would be equal to 30 times 9, which in this case is 27039 is 27, right? Okay. And then it says together they sold a total of 300 homes. So you could check your answer now to check what numbers you're going to add to check your answer?
The 270 plus the H was 30.
Plus 30. And that gives us 300. And the question actually said that together they sold 300. So that works out for our solution. Okay. All right. So you're going to go ahead and do this one. Miss Roll, I want you to take the lead on this one.
Okay.
Okay. So you could read the question and then tell me what the unknowns are and so on.
Okay, so Sue and Carol sells appliances from Master Appliances. Together, they sold 360 items in December. Sue sold twice as many items as Carol. How many items did each sell? So unknowns would be, sorry, the unknowns would be the appliances that Sue and Cara sold.
Sue and Cara sales. Oh.
And
and your variable you choose with who sold the least amount.
Cara sold the least.
Okay, so you're going to use the variable to represent her. So what variable are you going to use?
B.
Okay, so let's use B. So how much would Sue's sales be then if Cara is B?
Her sales would be Sue sold twice, so 2B.
2B, right? Okay. So what's the relationship you're going to express here now?
So it would be 2B plus B.
Equals?
And that would equals 360.
360. Okay. And
So then
solve that.
It will be 3B equals 360.
So B equals
360 divided by 3
equals
120.
20. So that 120 would represent whose sales?
Carl.
Cara, yeah. So if you want to find Sue, it would be equal to?
Sue would equal to 120 divided by, that's right.
Remember, Sue sold twice as many now. So if Cara sold 120, Sue sold twice as many.
Okay, so it would be 120, no, give me 1 minute, sorry. So it'd be 120 times 360, no?
See, look here. What is Sue's sales represented as in the table?
It's represented as a 2B.
2B, right. So if Cara is B and you worked out B to be 120, then Sue would be 2B. So how are you going to find what 2B is? It'll be twice Cara's sale. So how are you going to find twice Cara's sale?
I have a mind lapse. Give me 1 minute. Let me just look at the old. So it'll be 120 times 2.
Okay, times 2, which is equal to 240. Okay. Now, it says together they sold 360. So how can you check your answer to see if it is correct?
So you would add the 240 plus the 120.
Okay, equals 360. All right. And that, okay. All right. Thank you. Miss Roll. Yeah. Okay then. Okay. So I'm gonna move on then. Thank you. Now this one is a little bit more involved. Solving word problems for the unknown. Calculating the unit and dollar sales when total units are not given. So I'm going to read this one. It says, Andy sold watches, and I guess those watches are for $9, and clocks, $5 at a flea market. Total sales were $287. People bought 4 times as many watches as alarm clocks. How many of each did Andy sell? What were the total dollar sales of each? Okay, so we're looking at 2 sets of things here. We're looking at watches and clocks. Now it says that he sold, or people bought 4 times as many watches as clocks. So clocks were the ones that were being sold for the least amount. So you sell less clocks than watches. So that's why we use the variables here to represent the clocks. And since we use C for clocks and he sold 4 times as many watches, then of course it would be 4 times C to represent watches. Now they didn't tell you the total amount of watches and clocks that were sold. We don't know what the total amount, but they told us what the dollar amount was. The total sales in dollars was $287. So in order for us to form an equation, we have to involve the prices in that. So you will see there that for C, the watches were sold for $9, and the clocks were being sold for $5. So we have an additional column with this question to represent the prices. So 4C represents the watches. They're sold for $9. So 9 times 4C gives us this 36C. And then here, the clocks for $5, and we sold C amount of clocks, so C times 5, which would be 5C. So now, because you are told the total sales was 287, you're going to combine the 36C and the 5C, and that gives you your 287. So if you write this in equation form, it'll be 36C plus 5C equals 287. So that's how we would approach that, because they didn't tell you the total amount of watches and clocks sold. They told you the amount, the dollar amount. So you have to include that dollar amount in your equation using the prices that were given for the clocks and the watches. Now, when you add 36C plus 5C, what did we get?
41.
Okay, so 41C is equal to 287. So C then will be equal to 287 divided by 41, which is equal to that 7.
Yeah.
Okay, so that is telling us then that he sold 7 clocks. Okay, and how we're going to find out how many watches he sold? How many watches did he sell if he sold 7 clocks?
7 times 4.
7 times 4. Okay, that's 4 times 7 equals 28. All right. So we could say he sold 7 clocks and he sold 28 watches. But they don't only want the amount of clocks and watches he sold, they also want to know what were the total dollar sales of each. So how are we going to find the total dollar sales of each?
For clocks, it'll be 7 times $5.
Also, so clocks equals 7 times 5, because they were being sold for 5 each. That would be equal to 35. And so for watches,
It'd be 28 times $9.
okay, 28 times 9. And what is,
252.
okay, equals 252. And how could we check our answer?
$252 plus 35 is $287.
Okay, so in our check, we could say 252 plus 35 equals 287. That's our check. Okay. All right. So this one introduced another level because you are told how many clocks and watches in terms of the 4 times as many clocks and watches, but you weren't told how many altogether, but you were given the price for the total sales. So since you're given the price of the total sales, you're going to use that price along with the amount of each that was sold to solve for the unknown, which in this case would be the number of clocks sold, which was equal to 7. And once you get that, then you could work out how many watches were sold. And then you could work out the amount each was sold, the amount of sales for each. All right, so I'm going to give you one similar. Look at this one. And I want Miss Heald to take the lead in this one. Miss Heald, are you still there?
Yes.
Okay. All right. Miss Thompson, I don't think I've heard from you. So I go. Okay, Miss Heald, go ahead.
And that was just me who was talking though just now.
Yeah, it's just that, you know, I'm not exactly used to all the voices yet. Because yeah, sorry. Okay then, Miss Thompson. Okay, I'll take you as participating. Okay, Miss Heald, go ahead.
Plus furniture ordered sleepers for $300 and non-sleepers for $200 that cost $8,000. The company expects sleepers to outsell non-sleepers 2-1. How many units of each were ordered?
Mhm.
What were the dollar cost of each?
Okay. So what are we looking for now? Unknowns.
We are looking for how many units were ordered and the dollar cost of each.
Okay.
So
So
unknown.
we're gonna start off then with the two types that we have, or what? What are the two types of things we're dealing with?
The sleepers and non-sleepers.
Okay, so we have sleepers and non-sleepers. Okay. And in which one we sold the least of?
Non-sleepers.
Okay. So we're gonna use a variable to represent that one. What's the variable?
N.
Hmm?
N.
Okay, so you're gonna use n, okay. So if you're using n for non-sleepers, then sleepers would be what?
2N.
2n. Now they didn't put a column here. We need the
price.
price. Okay. So for the non-sleepers, it is how much?
$200.
200. And the sleepers would be
$300.
$300. Okay. So they didn't tell us what the total amount of those beds were, but they told us the total dollar amounts. So let's now work, let's now work out in algebra form what the sales amount for the sleepers were. How are you going to do that?
We have to do, I think it should be 2 times the 300.
Okay, 2 times 300 times n gives you
600 and or and 600.
600. And normally we put the number first and then the letter.
Right.
And then for the non-sleepers, Miss Hill,
Yes, the
how are you?
non-sleepers would be N times 200.
That would be 200 n. Okay. So now we want to write an equation to represent that, because you know that the total cost is 8,000. So how would you write that as an equation? You know that the sales for sleepers is 600 n, non-sleepers is 200 n, and the total sales is 8,000.
600 N plus 200 N equals 8,000.
8,000. Okay. So of course then 800 n is 8,000. So n would be equal to what operation we're going to use to find n?
You have to divide it by
Divide by
800.
800, which gives you
4 I get
You got what?
10.
10. Okay. All right. So that n equal 10 is telling us what?
That's telling us that the unit that they ordered for non-sleepers is 10.
Okay. So we have 10 non-sleepers. And then how many sleepers?
We have to times the 10 by 2.
2 times 10, which would be equal to 20 sleepers. Okay. So if we got 10 non-sleepers and 20 sleepers, how much money did we spend on each? How much money did we spend on the non-sleepers?
Non-sleepers 10 times the 200.
10 times is $200 each. Okay. 10 times 200 gives you,
2,000.
okay, $2,000. And then the non-sleepers, it was 20 of them. And how much each one costs again?
$300.
And 20 times 300 gives us,
6,000.
okay, 6,000. So we spent 6,000 on the sleepers. And altogether, how much did we spend again?
8,000.
So if you add the 2,000 plus the 6,000, you do get 8,000, right? So that's that. Okay. Mhm. So that's it for that one. All right. So I am going now to move to the last one, number 6, which is kind of similar, but have a little difference. In this one, it says calculating unit and dollar sales when total units are given. All right, so this time they tell you what the total units are, but they didn't tell you the total costs. So in this other one, you're told what the total cost is, like here it was 8,000. But in this question, you are not given the total cost. You are told what the total amount, in this case, the total sales. Okay. Okay, so let's read this one. It says, Andy sold watches for $9 and clocks for $5 at the flea market. Total sales for 35 watches and alarm clocks were $287. How many of each did Andy sell? What were the total dollar sales of each? Okay, so the watches cost $9, the clocks cost $5. The total sales for 35 watches and alarm clocks is $287. How much of each? Okay, so in this case, oh, do we know? It says, do we know which one he sold the least amount of? Does it tell us But which one he sold the least amount of?
Because he sold watches, the least amount of watches.
How do we know that?
Because he sold, at the flea market tools, so the total sales for, oh, my bad, no.
We don't know the amount of each.
You don't know of each.
Total
No.
amount.
Yeah, we don't know. We don't know. They didn't tell us. You see, in this other question, it says the company expects sleepers to outsell non-sleepers 2-1. So you know right away that the non-sleepers was the ones that they sold least amount of. But here, it doesn't tell us the relationship in terms of how many of each was sold. They just tell you that one cost $9 and one cost $5. And they told you that in total, they sold 35 watches and alarm clocks, and the total was $287. But you're not sure if they sold more watches or more clocks. Not sure about that. All right. Now in your book, I thought I copied that, but I don't see it on the slide. But if you look on page 126 of your book, it says that the note under the question says, the more expensive item is assigned to the variable first, only for this situation to make the mechanical steps easier to complete. All right. So the more expensive one was the watch. And so that's why they give that. But you don't necessarily have to use the watch. You could have used the clock. Okay, since they didn't tell you which one was the least amount that was sold, then you could use any of them to represent, for the variable to represent. But they suggest, they put an asterisk here. So if you look on page 126, you'll see what asterisk represent, that they chose the one with that was more expensive to represent the variable width. Okay, so in cases where you are not given any idea which item you sold the least amount of, if you know what the prices are, you would use the variable for the one that's more expensive, because it makes the working a little easier. But you don't have to do that. You could use the variable for the least expensive one, but it's just that the working would be a little bit more involved. Okay, so here they use W to represent the watches. Now, why do they have 35 minus W for clocks?
Because once we know the amount of watches, so we could subtract that.
Okay, so altogether, we sold 35 watches and clocks. So since you use W to represent the amount of watches, that means that you have to take that W away from 35, and that will tell you how many clocks were sold. All right. So unlike the other one where we were doing multiplication, in this case, we are doing a subtraction to work out how many of the clocks were sold. Watches were sold for $9, clocks were sold for $5. So altogether then, 9 times W, that's 9 times the W, plus $5 times the 35 minus W, that gives us the total sales, which was 287. Okay? So that's the equation we'd have there. So we'd say 9W plus 5 times 35 gives us what? What's 5 times 35?
175.
175, you said?
Yes.
Yes, sir.
Okay, 175, okay. And that's minus 5W equals 287. All right. So you multiply the 5 times the 35 and then the 5 times the W. So that's how we get that 175 minus 5W. So we're going to have to rewrite this now and put the like terms together. So 9W minus 5W plus 175 equals 287. 9W minus 5W gives you what?
4W.
Okay, 4W plus 175 equals 287. So 4W equals to 287 minus
Minus
175.
175.
4W equals
112.
112.
Yes, sir.
Okay. 1, 1, 2. So W then would be equal to what?
112 divided by 4.
28.
28.
12 divided by 4 equals 28. Okay, now what is that 28 telling us?
That's the amount of watches that was sold.
Okay, so that's the amount of watches that was sold. So to find the amount of clocks sold, what you're going to do?
35 minus 28.
Okay, so 35 minus 28 gives us
7.
7. All right. So in other words, then we sold 28 clocks. Sorry, not clocks.
7 watches.
Sorry. 28 watches sold. And 7 clocks sold. Now they want the dollar sales for each. So the watches were $9 each.
8 times 9.
Sales for watches would be
252.
okay, 252. That's 9 times 28. You said 252. And then sales for clocks.
7 times 5.
7 times 5, which is
35.
35. Okay, so that should be a dollar sign here, dollar sign there. And the total sales, it says, was 287. So how are you going to check your answer?
252 watches plus $35 in clocks equals
Okay.
287 total.
Would give you. Okay, so your check then would be equal to 252 plus 35. Okay, and that gives you 287. Okay, that's just your check. All right. All right, so let's look at this next one. Mr. Butler, I want to take the lead in this one. So Butler, you there?
Maria's Pizza sells bulk
Okay.
pizzas at $7,
Mhm.
and cheese pizzas at $6.
Okay.
And March, Maria sold 280 pizzas for $1,800 in total. What is the dollar sales price for each?
Okay.
And so the unknown is we're finding the sales price for each cheese and each meatball pizza.
Okay, so we have in meatball. And we have in cheese. Do we know which one we sold the most of or the least of?
No.
No. So what the book suggested is that you use the variable for the one that's more expensive. So which one is the more expensive one?
The more expensive is the meatball at 7.
Okay, so that's what variable you're going to use here?
You could use P.
Okay, so use P. So if P represents meatball, then how would you represent the cheese?
I guess you could use C.
No, we're going to use that same P, but we have to do something with the P. How many pizzas did Maria sold? Maria's
288.
Okay. But of that 288, P amount was meatball. So how much was cheese? Remember now, we're choosing
You didn't
P.
say how much, you just said the price.
Yeah, but we chose P to represent the amount of meatballs. So we're trying to figure out now how many cheese pizzas were sold. But we know that in total, 288 pizzas were sold. So if you sold 288 pizzas and P amount was meatballs, how would you find out how many cheese pizzas were sold?
You could do 288 minus P.
Right, very good. So that's 288 minus P. All right, now we need to put a column in for price here. So the meatballs was being sold for $7 and the cheese for $6.
Okay.
So now, if you want to represent meatballs, that would be 7P, and the cheese would be 6 times 288 minus P. Right. So let's write that equation. So tell me how you write the equation.
So it would be 7P.
7P,
Plus 6. 288 minus P equals 1,800.
1,800, right. Okay. Okay, so that's going to be 7P then, plus.
And then we work the bracket. 6,288 is 1,728 minus 6P equals 1,800.
Right.
I guess we could move, so we can cancel out the 1,728.
So that's 7P. You're going to move that 6P next to the 7P.
Right.
Equals 1,800 minus 1,728.
So that gives 72.
Okay, so P equals 72. All right. So P is 72. So that means you sold 72 meatball pizzas So how are you going to find out how many cheese pizzas were sold?
You gotta subtract 288 minus 72.
Okay, 288 minus 72 gives us
216.
216.
216. So it's 72 meatball and 216 cheese. Now they want to know what is the dollar sales price of each. So we need some space and write it over here. So we're gonna go right here and do the working for that. So for meatball, how would you find the dollar sales price for meatball?
72 divided by 7.
Divide. It's 72 is 70. Why do I even put a dollar sign here? That's wrong. Yeah. How many meatball pizzas we sold?
Other than that, 72 divided by 7. No.
How many meatball pizzas we sold?
72 times 7?
It's 72 times 7.
Right.
We sold 72 and each one is $7.
Okay, we got in dollar sales price. Look at that.
Yeah. So 72 times 7 gives us a total of
504.
504.
okay, 504.
$4.
And then for cheese,
Be 216 times 6.
216 times 6 gives us a total of
1296.
1296. So your total then would be, according to them, the total was 1800. So to check your answer, you could check to see if 1296 plus 504, what does that give you?
1800.
1800. Okay, which is what the question suggested. Okay. So we move from the simple to the not so simple. Okay. All right, so that was step number, so situation number 6. And so with this type of situation, you don't have a sense of which one you sold the least of. So you just choose according to your book, the one with the highest value. But if you choose one with the lowest value, you will still be able to work out the answer. It's just that, it would be a little bit more involved, but you would follow the same steps as we did here. Okay. So I think that's it for today as far as this chapter is concerned. We have covered all the areas. Now what you need to do is to practice. Practice. Okay. So your homework questions are shown here, and I already set your email for 11 o'clock. So if you check your email, all of you should have received an email with this PowerPoint for today's lesson. And so your homework questions should be there. I think I also sent, for those persons who still don't have the book, I also included the pages from the book, and I'm hoping by next week, everybody would have their book. Because the office said they were going to order some more. Okay. And so I want you to attempt as many questions as you can. The answers are there in your on the PowerPoint at the end. And if you have any issues with arriving at any of the answers when we meet this week, we're going to meet Wednesday, Thursday, depending on your schedule. We could discuss at that time any of the questions you have. Okay. Now, in your let me see something. Okay, so I think I also sent the test to you, so you could check your email. I scanned it, and you should see the test that you did on Saturday. Now, I also sent another test to you, which is optional. You don't have to do it, but it's set up similar to this because I realize that some of us may need some extra practice. Have you all check your email? You see the stuff I sent so far?
Yes, sir.
Okay. So let me check this now.
No, I see it.
You didn't see it?
No, I say he did.
Oh, you did. Okay. All right. So let me check something sent. Now, I want to, let me see. That second test, could they please see attached today? No, that's that's 1B. Okay, so I sent another version of the test for practice. Now, what I'm going to do for the next few minutes is go through this test. Now, I think one person got 100%, which was excellent. And we had varying scores. Some persons did fairly well, but I know some of you joined late. So some of the concepts you may need to review, and that's why I want to go over this test. And I gave you a very similar test set up the same way. And so what I want you to do, and I want you to just make sure to follow the instructions that I have on the email. I said the test is optional. If you decide to write it, please print the test. So I don't want it on any folder sheets or any lined paper. So you're going to print the test. You're going to write on the printed copy, and then you're going to scan the paper back to me, right? And you have until Monday. So I'm figuring if you don't have a scanner at home, you should have something at work. You're going to scan the paper back to me by the end of the day on Monday. The end of the day is midnight, but you don't have to wait till midnight Monday. And once you do that, I will mark it and I will average the score you got on that together with your current score with this test to improve your grades, okay? Nobody should be getting less than 100 on that second test. So if you got 100 on that and your first test was 60, 100 plus 60 divided by 2 will give you 80%. So the more you can get on that second test, the better you can increase your average score for the two, okay? So is that clear? Any issues with that? Okay then.
Okay.
All right, okay. So let me go over this test here now. Where's my answer sheet? All right, now some of these were, we didn't have any issues with. Number one was 9 and 8/9. So if you have the test there, you could just do your corrections. And as I go through, if you have any questions as for the procedure, just let me know, please. Number 2 is 59/3. Sorry, 1B. And 1C, they should be 63. I don't think anybody got those wrong. Okay, now for question 2, we had some problems here. You could do the whole number first. 9 plus, sorry, okay, 9 plus 6 or 6 plus 9 equals 15. And then you do the fractions. 3/4 plus 1/8. We could use a common denominator of 8. And then 4 into 8 is 2. That's 2, 3 is 6. And that's 1. That's equal to 7 over 8. So your final answer should be 15 and 7 over 8. That's for number 2. Number 3, you would say 9 minus 5 is 4. And then you have 1 over 4 minus 3 over 8. Again, this time you're still using that same common denominator of 8. So that becomes 2 over 8 minus 3 over 8. Now you can't subtract here, so what you're going to have to do is borrow from the 4. So if you borrow from the 4, you're going to be left with 3, and that 4, that 1 that you borrow becomes 8 over 8. That's a whole number. So 3 and 8 over 8 is the same as 4. Then you're going to add that 2 over 8 and then subtract the 3 over 8. So 8 and 2 is 10. 10 minus 3 is 7. So that's 3 and 7 eighths. Okay, so any questions before I move on? The first page. No? So we can move on then.
I guess.
Okay. Let me see, Mr. Messidor, you got all of that? Hello?
Yeah, sorry.
Yeah.
Yeah.
You got it, okay. I just want to make sure. Okay then. All right, so going to number 4 through 7, page 2. Now, when it comes to multiplication and division, we have to convert any mixed number into improper fraction. So 3 over 4 is equal to 15 over 4 times 8 over 9. So you're going to do canceling here. You can cancel 4 into 4, 1, 4 into 8, 2, 3 into 9 is 3, and 3 into 15 is 5. Equals 5 to 10 over 3. That's equal to 3 and 1/3. All right, so those people who if you got anything wrong, I'm trusting that you're correcting as we go along, so that when you do this second version of the test, you have some idea of the steps. Okay, the next one is a division. Again, once you're dividing or multiplying, any mixed number must be changed to an improper fraction. So that's 3 5 15 and 3 18 over 5 divide by 3 over 2. So when it comes to division, we have to convert that to a multiplication, which means you have to invert the divisor. So that's going to be 18 over 5 times 2 over 3. And we can cancel here. 3 into 3, 1. 3 into 18 is 6. 6 2s are 12 over 5. Okay, and 5 into 12 goes 2 times, remainder 2. So it's 2 and 2/5. Now, some of you lost points because you didn't reduce your fractions to lowest terms. The question says reduce to lowest terms, okay? So if you see where you got 2 points instead of the full 3 points, it's probably because you didn't reduce to lowest terms.
Wow.
Okay. Question number 5. Name the place position of the underlying digits. I think most people got that one. It should be hundredth, HUNDREDTH. And then the next one says round to the place indicated to the nearest thousandth. That should be 6.842. 6.842. Okay, change that number there to a decimal, the 0.0097. Right, as a decimal fraction, that should be 825 over 1,000. And then C is 0.48. I don't know why I gave 2 points for that, but anyway. All right. Number 7, you are supposed to rearrange vertically and add. This is another one where you are told specifically to rearrange vertically and add. Some people just put the answer down. The answer is only worth 1 point. You got 2 extra points for working. All right. So you should have 0.005 to 0.18114.000 and 1.200. You do that, you add, and your answer should be 215.386. Any questions there?
Mr. Allen, number 6C. You just write the answer. How did you get to that answer?
6C?
Yes.
12 divided by 25.
Okay, that's it. All right.
Yeah, that one really should have just been 1 point. But yeah, because you could just put that in your calculator and work it out. It didn't ask for any working. Yeah.
Okay.
Mm-hmm. All right. So moving on to okay. Question number 8. Okay. Most people only gave the answer for number 8. They didn't rearrange vertically and multiply. It's supposed to be 6.24 and 3.9. And then you do that. You say 9 fours are 36. Carry 3. 2 9s, 18 and 3, 21. Carry 2. 6 9s, 54, 56. Then you put your 0. 3 4s, 12. Carry 1. 3 2 6 and 1 7. 3 6s are 18. Then you add 6, 3, 3, carry 1, 8 and 6 is 14, carry 1 is 2. And then you have 2 places here, 1 place there, so your answer should have 3 places. So you're going to put as your answer 24.336. But you need to show you're working because it did tell you to rearrange vertical and multiply to get the full points. Same thing with number 9. It says divide using long division method, rounding your answer to the nearest 100. So this one, you had 6.5 divided by 0.07. To work to do a division in decimal, you have to make the divisor whole. So you have to go 1, 2 places here to move the point to make this a 7. So if you do, you have to move this, do the same thing with the number you're dividing, 1, 2. So the first point would move it after the 5, and the next point you have to add a 0. So that would be 7 into 650. All right, so you say 7 into 65 is 9, and 7 nines is 63. That's 2, bring down the 0. 7 to 20 is 2. 2 sevens, 14. Bring down, that remainder would be 6. There's nothing else to bring down, so you put a point and you might add a couple zeros. Okay. So you put your point here also. And then you put another 0. 7 into 60 is 8. 7 8 is 56. That's 4. Bring down another 0. 7 to 40. That's 5. They say to the nearest 100, so that means you need 2 places after the point. So we have to go to a third place. So you say 5 7 is 35. So that's a 5. And you bring down another 0. 7 to 50 is 7. So you could stop there because you only need to go to the nearest 100. So that's 92.857. So since the number after the 5 is 5 or more, you're going to be 92.86. Okay. Number 10, calculate the simple interest. I think most people got this one. That would be 5,000 times 0.07 times 6 out of 12. I think one person didn't put the point in the right place. They used 0.7 instead of 0.07. That was 7%. That's so you have to move the point 2 places to the left. So that will give you $175 for your answer. Okay, now in this next question, it says complete using the exact interest method, meaning that it would be 365 days because it's exact. If it wasn't exact, it would be 360, which is the ordinary interest. First thing you have to do is find the exact time. So you're going from May 19th to August 23rd. May 19th, oh, I'll make this out. May 19th. May 19th is May 19th. Let me see, May. That's 139. And August 23rd. August 23rd is 235. So 235 minus 139. 235 minus what we said again,
39.
39. I think that gives us 96. So this here exact time should be 96 days. You get 2 points for that. That's 2 points if you got that part right. And then once you find that out, then you're going to say now the interest would be $10,000 times the rate, which is 0.08, times your time, which is 96 over 365. And that works out to $210.41. And then so that answer is what goes right here. And then the maturity value, you're going to say 10,000 plus the 210.41. That gives you 10,241 point. Sorry, no, that's not the right thing. 10,000 $210.41. And that's what goes in that box. Okay, any questions with this page?
Yes, I have a question. I'm not clear when you get to the, is it like 596 over 365? Like, I don't understand that calculation. How does that work?
Okay, so when you are given the dates, like August 23rd and May 9th, there's a table that we use. I can't remember which page it's on. It's on, I think it's page 18. Let me see,
7
in your textbook. But if I give you a test, I'll put the table on the test. But your book also have the table. But you see right here, this table, this is the table you're going to use. And you're going to look for the two dates. So the one date is August 23rd. So you go to the August column and you go all the way down to 23rd. And you will see 235. And the next date was May 19th. So you go to May column and you go all the way down to 19, and that's 139. And so to find out how many days between those two dates, you just subtract the 139 from the 235, and that will give you, in this case, 96. All right. So it all depends on the dates that you're given, but whichever dates you're given, you go to the table, find the two dates, and whatever number is there, you subtract those two numbers. You subtract the smaller number from the bigger number, and that tells you how many days fall between those two dates.
Okay, and then you did this, what it is, the simple interest. I got that part, but it's just this calculation where you got 210.41. I don't understand how you answer.
Okay, so the simple, so the principal is $10,000. The rate is 8%, so that's the 0.08, and the time would be that 96 over 365, because we have 365 days, and the question asks you to use the exact interest method. So when we were doing that chapter, there's two things we could use. We could use the ordinary interest. If the book says ordinary interest or the question says ordinary interest, you would put 360 as your denominator. But because it says exact interest, they're asking you to put the exact number of days in a year, which is 365. So you put the 96 over 365, and that's your time. Okay, so anytime you're given days, then you're going to use either 360 or 365 as your denominator. And then you multiply 10,000 times 0.08 times 96 divided by 365. And that's how we got the 210.41. And that's your interest. And then the maturity value, now you're going to add the interest to the principal, and that's what gives you the maturity value.
Okay.
Any other questions for that page?
Can you redo number 8? Can I
Could you repeat that?
Redo number 8.
Okay, number 8. Okay, with number 8, I have it displayed there. It's 6.24 times 3.9. You multiply by the 9 first. 9 4s are 36. Carry the 3, 9 2 is 18, and 3 is 21. You put the 1 down, carry 2. 6 9 is 54 plus 2 makes 56. So that's the first line. Then you're going to multiply by the 3. 3 4 is 12. Of course, you're going to put a 0 first to hold that place. 3 4 is 12. Then carry 1. 3 2 is 6 and 1 7. 3 6 is 18. Then you add 6 and 0 is 6, 2 and 1, 3, 7 and 6, 13, carry 1, 8 and 5 is 13 plus the 1 makes 14, carry 1, 1 and 1, 2. So you get the 2, 4, 3, 3, 6. When you're multiplying decimals, you have to check to see how many places are in the numbers that you're multiplying. So 6.24, there are two numbers after the place, and the other number is, 3.9. There's one number after the place, the decimal point. So altogether, you should have three numbers after the point in your answer. And that's why we have three numbers after the point here. So even we just put 2, 4, 3, 3, 6 when we do the multiplication, but then we have to adjust the point based on the number of decimal places in your numbers that you're multiplying. So that's how we got the 24.336. Okay, so we're going to move now to the last page. That seems to be the most challenge for some persons. So with question 12, you're asked to find the principal. And remember, we had this little triangle thing here. I think it was this. Principal equals, all right, sorry, not principal, interest equal principal, rate, and time. All right, so you want to find the principal. So principal would be equal to the interest based on how this is designed over rate times time. That's your principal. That's what the question asks you to find the principal. All right. So the interest in this question was $46.88. The rate is 12.5%. So to change that to a decimal, that's going to become point. You move the point two places to the left, it becomes 0.125. And then you multiply by the time. And they ask you to use 360 days. So your time then would be 90 days. That's 90 over 360. Then you enter that in your calculator. And you should get $46.88. Okay, now a number of persons use the wrong method to do number 13. Remember now, when you have a question like this with simple interest, the first thing you have to do, if you are making payments before the end of the loan period, the first thing you have to do is work out how much interest is due on the day when you make the payment. So you borrow $17,000, and on the day you're making the payment, that was day 65. So it's principal times rate, that's times rate, which is 12% in this case, which would be 0.12. And you're making the payment on day 65. And what type of, we're using ordinary interest, so it would be out of 360. So when you do that calculation, you get 368.33. That is the interest for that first payment that you made. So when you make that payment to the bank is going to take out the interest out of the payment. So you made a $2,000 payment on day 65. So 2,000 minus 368.33 will leave you with 1631.67. That's what the bank is going to credit your principal with. They're going to take that away from your principal. So you make a $2,000 payment on day 65. The interest due on that day is $368.33. The bank is going to take that away from the $2,000, and now your principal will change because we're going to take that $1,631 from the $17,000 which you initially borrowed. So $17,000 minus, subtract, sorry, that should be subtract 1631.67 gives you 15,368.33. So your principal is now changed. It is no longer 17,000. It's now going to be $15,368.33. That's your principal. And you made another payment, but this time you made a payment on day 89. Okay, so that how many days away from day 65 is day 89? How many days away from day 65? From day 65 is day 89. Anybody?
Day 90 was 65, somebody.
How many days away from day 65 is day 89? You have to subtract.
24 days, 24 days.
24 days. So when you make your next payment, 24 days would have passed. So you're going to work out how much interest is due for that next 24-day period. But remember now, your principal is no longer 17,000. Your principal is now $15,368.33. And the rate is still the same, 12%. But this time, it's 24 days past since your first payment. So when you do that calculation, the interest due for that payment is 122.95. Again, the bank is going to take out that 122.95 out of your payment, and your payment was $4,000. So they're going to say 4,000 minus 122.95, and that gives you 3,877.05. Okay, so that's how much money now will be applied to your principal. So even though you gave $4,000, the bank has to take out its interest first of $122.95, and that $3,877 that's left, they're going to reduce your principal by that. So you're going to save 15,368.33 minus the 3,877.05. And so your new principal now becomes $11,491.28. So this is what your principal is now. So you didn't make any more payments. You only made two payments. You made a payment of $2,000, another payment of $4,000. So you still have some money to pay because you still have $11,491.28. So you're going to deal with that at the end when the loan is supposed to mature, the final payment. So you made a payment on day 89. The loan is for 120 days. So how many days left to finish the loan if you made a payment on day 89? How many days left on that loan? Anybody? How many days left on the loan? Are you all with me? How many
Sorry,
days?
31 days.
31 days left. Okay, so we have 31 days left on the loan. So what you're gonna do now is find out how much interest is due for the last 31 days. So what you do, your principal is now $11,491.28. You're gonna find out 12% of that for 31 days. That's how much time is left on the loan. When you work that out, you're going to get $118.74. Okay, so you owe the bank the 11,000 plus the interest for that last 31 days. So your ending balance then is going to be 11,491.28 plus 118.74. When you add those together, your ending balance is going to be $11,610.02. Okay. So that's it for that question. All right, now, like I said, the worksheet, the test that I sent to you, it has it's set up very similar to this. So once you get yourself oriented and you understand what you're doing here, you should have no problem doing very well on that makeup test. So I give you an opportunity to make up for those who didn't do so well on this. If you already get 100, it makes no sense to do it over. But the other persons, you have that option to make up. Okay. Any questions with that last one? Yes, no? Or somebody needs to turn the mic off. Okay. Now, I want
like everybody in the bed with him, boy.
Okay, who is this then?
Already?
Mr. Is that Mr. Butler? Or Mr. Okay. Okay, I have one last thing to do. I want to, let me see, home page. I'm going to be sharing, let me see if I could find that. Okay, it's here. Google Drive. Okay, let me see. Yeah, that's calculation. All right, so I I guess y'all could see this, my screen, right? Are y'all seeing the screen?
Yes, sir.
Okay.
Yes.
So what I have here is a progress report. I haven't shared it yet, but I'm going to share it as soon as I'm finished here. And you will see at the top, okay, your name will be somewhere up top where it says name. And then you see all the dates that we're supposed to have class, the dates. Okay. And so we have 14 classes, and then you see the next column says attendance. So I'll put present, absent, or partial. Now, if I call you in class and, you know, I don't hear from you, then even though you may be present on the screen, but if you're not communicating, then I'll put partial. But if you didn't show up at all, then you'll be absent. So if you see partial there, it means that I call you more than once and I didn't get a response from you. Partial. But if you were communicative and participative throughout the class, you're present. And if you didn't show up at all, then of course it would be absent. And so the next column shows the different chapters we'll be working on. And your homework, you will see the score for homework. Once you show me your homework, you get 100%. And then at the bottom here, you have your test score dates for the 4 tests. And then you'll see the test scores show up. So right now, all of you should have a score for the first test. So when I show that to you, you'll see your score. And if you do the makeup, then I will change it to reflect the new average. And then the next section has the your midterms, which coming up, the first one will be the 30th of October. And then your scores for midterm would go in these 2 sections. The first one for midterm 1, the second one for midterm 2. Okay, and then we have a further breakdown in terms of your homework, your tests, your midterms, and then yeah, okay? So I will share that with you today. Now, what I want to do is to look at it. And if you have any, because now in some cases, I did not receive any homework from persons. So if you see NS, it means not submitted. If you know you submitted it, then you could just, you know, send me an email, tell me when you send it, or you could resend it. And once I see it, I'll change the score. Now with homework, you could submit your homework whenever you get it completed. Take a picture, send it to me, and I'll input your score. If you were present and you have a query, you see me put you absent. As far as I know, I think I have been checking, but just in case I make a mistake, you can let me know and I could make the adjustment. But I'll be sending this to you today. And if you have any queries, you could always send me an email and I could make the adjustment. Okay, so I think that's it for today, unless you have a question for me. We meet this week, Wednesday or Thursday, depending on your schedule. And then we meet again on Saturday, all being well. Any questions?
No, sir.
No? Okay, well, thank you for your attention. We went over a little bit today, but I hope it was beneficial to you. Okay, so until Wednesday or Thursday, you keep safe. Bye-bye.
Okay, we do the same.
Okay.